Okay, chapter 2.2, summarizing important features of a numerical distribution. Let's take a look at some of the key features of a data set: the shape, the center, and the horizontal spread or variability. So we're going to keep these concepts somewhat informal for now until later, and later on we'll look at some more formal ways of doing this, some calculations for it, and some formulas. So number 2, often the first question asked about a distribution is, what is a typical value? The answer to this question is somewhat subjective, but is concerned with the location of the center of the distribution. Let's take another look at the data concerning the maximum speed. Okay, so let's take another look at the data concerning the maximum speeds of the roller coaster from www.rcdb, rollercoasterdatabase.com. Following comparative dot plot contains the maximum speeds for the wooden roller coasters and also the steel coasters. All right, so our first question, what is a typical maximum speed for the wooden coasters? Well, typical, again, something in the middle, something towards the center. So if we look at our wooden coasters, you might pick something around 50 miles per hour. You may have something a little bit different, and that's okay. Right now, again, it's somewhat subjective. And what's a typical maximum speed for the steel coasters? If we look at the center of the steel coasters, looks like maybe somewhere around 60 to 65 miles per hour. So I'll put 65 miles per hour for right now. Okay. And then the question, how do these two centers compare? Well, if you notice, the center for the steel coasters is further to the right than the center for the wooden coasters. So we say that the steel coasters typical speed tends to be faster than the typical speed for the wooden coaster. Or we can just say that the steel coaster's typical speed is greater. Or steel coasters tend to be faster than wooden coasters. And keep in mind when we look at these typical values or typical speeds in this case, we're looking at the entire distribution, not just a single value when we get it. Right, so number 4, keep in mind that we may not all agree as to what the typical values are for a given distribution. Our goal is to get a rough idea of where the centers are so that we can make comparisons between the two distributions. All right, number 5, since the typical speed for the steel coasters is greater than the typical speed for the wooden coasters, we can say that steel coasters tend to be faster than wooden coasters, or that steel coasters have higher speeds on average than wooden coasters. This is an example of a statistical tendency. Number 6, how does the horizontal spread or variability compare for these two distributions? Does one type of coaster have a wider variety of speeds? So if we take a look, steel coasters go from here to here. It's like that's roughly 30 miles per hour up to about 120 miles per hour. And that's for the steel coasters. Wooden coasters, on the other hand, go from about here to here. It's maybe about 25 miles per hour up to 80 miles per hour. All right, so what we can see is that there's more spread or more variability with the steel coasters because they have more spread relative to the horizontal axes. And on those same lines, we can say that the wooden coasters then have less variability or less spread. Okay, so another way to think of variability is consistency. Which type of coaster tends to have more consistency in their speeds? Wooden coasters tend to have more consistency. Oops. And we can see this because it's just another way of asking about variability. So they have more consistency in their speeds because they have less variability. Okay, number 8, there are 3 basic characteristics of a distribution shape that we should look for. First one is the distribution symmetrical or skewed or neither, and we'll look at this in more detail on the next page. Second one, how many mounds or clusters does the distribution contain? And we'll look at that in more detail on the next page. And then, are there any unusual values present? Are there any values that don't fit the pattern established by the majority of the data? So for instance, let's say that we've got a large cluster of coaster speeds over on the left, and then we have one over here. That one's a little unusual compared to the rest. Right, so that looks like it's a little unusual, maybe a little bit fast. If we check our coaster data up above, some may argue that this one for the wooden coasters maybe is a little bit unusual in terms of its speed. It's a little less than the rest. Up here for the steel coasters, there's one that maybe on the higher end is a little bit more unusual. As you can tell, this is going to be somewhat subjective as well at this point. Okay, number 9. Let's take a closer look at the first of these 3 characteristics. The following 3 histograms are from page 45 of your text. Which ones appear to be symmetrical, which one is skewed to the right, and which one is skewed to the left? The one on the top left that deals with heights is symmetrical. Imagine drawing a line down the middle and folding it like a book. We'd see that the left side and the right side are fairly similar. So that's what we mean by symmetric. This one with ages is also somewhat symmetric. And if we cut it down the middle, put a line there, it looks like the left side and the right side are about the same. They don't have to be perfect, but they're similar. Right, this bottom left one, hours of TV per week, is what we refer to as skewed to the right. That arrow is there to emphasize that. So it's like someone took the tail of a distribution and stretched the right-hand side tail. This one on the left, dealing with grades, is the reverse. This one is skewed to the left. And for a similar reason, it looks like the left-hand tail is much more stretched out than the right-hand tail. All right, so a few things to keep in mind. Number 10, not all distributions will have one of these 3 shapes, but these shapes appear often enough to have their own names. Distribution of heights is symmetric, though not perfectly symmetrical. The shape is often referred to as a bell-shaped distribution. Distribution of ages is roughly symmetric and uniform. So uniform is referring to the idea that the heights of the bars are all roughly the same. Distribution of hours of TV per week is a right-skewed distribution. The tail on the right side of the distribution is stretched towards the larger values. The distribution of grades is a left-skewed distribution, since the tail on the left is stretched towards the smaller values. We'll see in a later section that the direction of the skewness is what skews your measures of center and spread. Okay, another aspect of shape to consider is how many mounds or clusters the distribution has. A unimodal distribution has 1 mound, a bimodal distribution has 2 mounds, and a multimodal distribution has more than 2 mounds. So number 12, the following sketches are idealizations of distributions of data. In real life, you won't typically see such perfect distributions. So which ones are unimodal, which ones are bimodal, and then use the last axis to draw an idealized version of a multimodal distribution. Right, so first thing to think about, again, these are models. So imagine it showing you the rough outline of a histogram. This first distribution is something that is symmetric, and it's also unimodal because it has 1 peak. So it's got a peak in the middle and unimodal. The second one to the right is also unimodal. Okay, so unimodal here and here. This one again also has just 1 peak. The next 2 are bimodal. So you've got bimodal down here and also here. Notice that these both have 2 peaks. Notice the peaks do not have to have the same height. So your modes don't have to be the same frequency. And the last one, multimodal, means it has more than 2 peaks. So your distribution might look something like this. And again, notice that the peaks don't all have to have the same height. We have a peak here, a peak there, and a peak there. In the case of the bimodal and multimodal distributions, it may not make sense to talk about a single typical value. Instead, it may be more appropriate to find a separate typical value for each cluster or group. In these cases, it may also be more appropriate to refer to the shape and spread of each cluster separately. Okay, so for example, if we go back to this one, we may want to consider this as 1 group or cluster and talk about its typical value. Same thing with this cluster, same thing with this cluster. Okay, number 14, outliers are extreme values that do not fit the pattern established by the majority of the other data. Determining whether a value is an outlier is somewhat subjective at this point. We will learn about one type of outlier test in a later section. For now, keep in mind that a potential outlier in a data set warrants further attention. You should check to see if the outlier is the result of clerical error or consider possible explanation for why the observation is so unusual. Okay, number 15, here's a checklist of things to include when describing a distribution. I want to include the center of the distribution, in other words, what's a typical value. Talk about the spread of the distribution, what's the horizontal spread of the values. Talk about the shape of the distribution. Is the distribution symmetrical, skewed, or neither? Is the distribution unimodal, bimodal, or multimodal? If it doesn't fit into any of those categories, you can still describe the shape, describe what you see. Potential outliers, do any of the values appear to be unusually big or small? And then are there any other interesting features? Are there any gaps? What are the minimum and maximum values?